Learning mathematics is very, very difficult to many people, second only to learning how to speak English. Do you have difficulty? Don't be embarrassed. It's a lot of people don't know what they're doing when they get up there and do their mathematics. We're going to introduce you today to Fort Bend Tutoring, honey. Personalized math tutoring is the solution.
This is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about multiplying decimals. What's up? So, we're going to start with problem number 1 here. We have 6 and 8/10 times 7. Anytime you're multiplying decimals, you do not have to line up the decimals. The only time you have to line up the decimals is when you're adding and subtracting. That's it. So all you have to do when multiplying is just line up the last digits together, just like this 8 and this 7. You see that? They're lined up because those are the last digits in each of their respective numbers. From there, you just multiply it out. So just multiply it as though it was 68 times 7. All right. So you'll have 7 times 8 is 56. I'm gonna bring down my 6. I'm gonna curry my 5 here. All right. All right. Curry like the spice. So, but for those of you that want to be technical, yes, I'm carrying the 5 here. Okay. So judgmental. So judgmental. So you have 7 times 6, which is 42. 42 plus 5 gives you 47. So I bring down 47. And then you will count the number of places that you have behind your decimals. All right, the number of place values behind the decimal. I have 1. You see that? That 1/8 behind the decimal there. I have 1 place behind the decimal in my original problem. So therefore, I start from the right and I move the decimal over 1 place to the left so that my answer here is 47 and 6/10, and this is it. That's problem number 1, ladies and gentlemen. Just like that. All right, I have more examples. Let's look at them. In problem number 2, we have 84/100 times 8/10. So notice how, once again, that last digit, those last digits are lined up, and I'll be multiplying these numbers as though it reads 84 times 8. So multiplying this out, I have 8 times 4 is 32, so I'm going to bring down my 2 and I'm going to curve to 3 there. I have 8 times 8 is 64. 64 plus 3 is 67. So I bring down my 67 here, and then I'll be counting the total number of digits I have to the right of the decimal points. So I have 1, 2, 3. I have this 8, this 4, and this 8 right here to the right of the decimals. So that's 3 places, right? So I start to the right of the 2 and I count 1, 2, 3 places to the left to end up with a result that is 672 thousandths. Now, the 0 to the left of the decimal is optional, so you can place it there or not. It's up to you. But this is the answer. That's right, 672 thousandths, the result of problem number 2. All right, let's keep things moving. Keeping things moving, so we're on to our next example, which is 6 and 3/10 times 4/100. Once again, I'm not going to multiply this out horizontally. No, never going to do that. But what I will do is rewrite this problem vertically. So it'll look like this. I'll have 6 and 3/10 times 4/100. Notice how I've lined up that last digit together. That's what you want when you're multiplying decimals. So here, I'm multiplying 4 times 3, which is 12. I'm going to curve the 1. I have 4 times 6, which is 24 plus 1, that extra 1 right there, gives me 25. And then I'm going to count the total number of digits I have to the right of the decimal point. So I end up with 1, 2, 3 places to the right of the decimals in total. So I start from the right and I count 1, 2, 3 places over to the left. So my result to this problem here is going to be 252 thousandths. And remember, the 0 to the left of the decimal is optional. Up to you if you want to write that out. Okay, so there's my answer. That's it. That was problem number 3. We started out with the problem written horizontally, and I immediately rewrote it vertically because I don't do it that way. Okay? I don't like it horizontally. It's not good. Don't like it that way. Problem number 4. Problem number 4, we have 8 and 27/100 times 54/100. That's right. And so I'll be rewriting this horizontally written problem vertically. So it'll look like this. 8 and 27/100 times 54/100. And remember, I'm lining things up by the last digit, not by the decimal. All right. And this problem number 4 here was just a coincidence that my decimals were aligned there. So multiply this problem out as though it reads 827 times 54. That's what you want to do. So 4 times 7 is going to be 28. I'm going to occur the 2. Then I have 4 times 2 is 8. 8 plus 2 is 10. I bring down the 0. I occur the 1. I have 4 times 8, which is going to be 32. 32 plus 1 gives me 33. So then I'd like to use a placeholder here. You may use a 0 or whatever you choose to use there. I'd like to use a little dot because I'm lazy. So I will be moving on to multiplying by 5 now. And you know what? I'm going to go ahead and erase these little reminders here away. So here we are, multiplying by 5 now. You have 5 times 7 is 35. I bring down my 5, I carry the 3. All right, that's an ugly 5 right there, but please ignore it. We have 5 times 2 is 10. 10 plus 3 is 13. So I'll bring down the 3 and I'm going to occur the 1. I have 5 times 8 gives me 40, and 40 plus 1 is 41. So I have 41 right here, and then I'm going to add this together. Yeah, adding those together there. So I bring down an 8, I have a 5 here, I have 3 plus 3 is 6, 3 plus 1 is 4, and I have another 4 to bring down. Then you want to count the total number of digits to the right of the decimal point. So I have 1, 2, 3, and 4 digits to the right of the decimal. So I start from the right and move my decimal over 1, 2, 3, 4 places to the left to end up with a result that is 4 and 4,658 ten-thousandths, and I have a box around my answer just like that. That, ladies and gentlemen, is how you multiply decimals. You got it. That's problem number 4, which means problem number 5 is coming up. So, problem number 5. We are multiplying negative 231 thousandths times negative 5 tenths. First of all, ladies and gentlemen, anytime you're multiplying a negative times a negative, the result will be positive. So I know my answer is positive. With that known, I'm going to rewrite this as 231 thousandths times 5 tenths. Just like that. Notice that I left off those optional zeros there. For this problem, they're not significant, so I didn't write them. So I'm going to start by multiplying 5 times 1, and 5 times 1 is 5. 5 times 3 gives me 15. I'm going to occur the 1. I'm going to occur the 1. I have 5 times 2 is 10. 10 plus 1 gives me 11. Yep. And now for the total number of digits to the right of the decimal, I have 1, 2, 3, and 4 places behind the decimal there. So I start from the right behind that last digit of 5 here, and I move the decimal over 1, 2, 3, 4 places to the left, and I end up with my result, which is 1,155 ten-thousandths, and this is the answer to problem number 5, ladies and gentlemen. Just like that. So remember, we decided what sign the result would be first. A negative times a negative is a positive, so therefore I secured the sign of the answer as my first step in this problem. Then I wrote it vertically and multiplied it out. That was number 5. Let's move on to our next problem, ladies and gentlemen. Our next problem here is problem number 6, where we have 7 8 tenths times 100. Now, as a shortcut, anytime you're multiplying by 100, all you have to do is move this decimal 2 places to the right. That's it. You move it 2 places to the right, you'll end up with 780, which is the answer. But let's say you wanted to show your work. Well, you'll rewrite it vertically as 100 times 7 8 tenths. All right, just like that. So I'm multiplying this out. I have 8 times 0 is 0, 8 times 0 is 0, 8 times 1 is 8. Then I use a placeholder to move me to the next place value. I'm multiplying by 7 now. 7 times 0 is 0, 7 times 0 is 0, and 7 times 1 is 7. And then we'll add these together. So I'll bring down 0, 0, 8, and 7 as I add these numbers together, and I'll be moving the decimal 1 place to the left because I have only 1 place to the right of the decimal there. So I'm going to move over 1 place and end up with 780 as my answer. That's it. 780 is the answer to problem number 6, ladies and gentlemen. That's it. Notice how we could have easily gotten that answer just by simply moving the decimal in our original problem 2 places to the right. So if you're multiplying by 100, you always move the decimal 2 places to the right. Or let's say that you're multiplying by 10, you'll move the decimal 1 place to the right. Let's say that you're multiplying by 1,000. Yeah, you'll move the decimal 3 places to the right. So you'll just follow that pattern if you're multiplying decimals by powers of 10. By powers of 10. All right, so I'm going to continue on to our next problem. That's right. Here in problem number 7, I have 100ths times 789 and 235 thousandths. That's right. I had to take that in first. So this is 100ths times 789 and 235 thousandths. Right. Well, oh, you're asking for a shortcut. Yeah. Well, the shortcut to this is, since I have a power of 10, this 100th here, with a place value to the right of the decimal, you will then move the decimal in this number here 2 places to the left. Yeah, if you multiply by 100th, you just simply move the decimal 2 places to the left. That'll be your answer. So your answer will be 7 and 89,235 hundred thousandths. But that's if you just want to do the shortcut. If you want to show your work, this is what you'll do. You'll have 789 and 235 thousandths times 100th, just like that. And then I'll multiply by 1. So this is going to be 1 times 5 is 5, 1 times 3 is 3, 1 times 2 is 2, 1 times 9 is 9, 1 times 8 is 8, and 1 times 7 is 7. All right, how many places do we have behind the decimal? To the right of the decimal, by the way. This is going to be 1, 2, 3, 4, 5 places to the right of the decimal. So I start from the right and I move it over 1, 2, 3, 4, 5 to end up with 7 and 89,235 hundred thousandths, ladies and gentlemen. Remember that shortcut I told you at the beginning? I said when multiplying by 100th, all you had to do is move the decimal 2 places to the left in the other number, and that would be your response. And now we have proven that. So I'm going to put a red box around my answer here, because that is the answer to problem number 7. In problem number 8, we have the following. We have -4 and 23 hundredths times 1,000th. Now, because we're multiplying a negative times a positive, your answer will be negative. All right? The answer must be negative. And then because I'm multiplying by 1,000th, similarly to the last problem, you're going to move the decimal 3 places to the left. And that will give you your answer. But let's show our work. So we'll have 4 and 23 hundredths times 1,000th, just like that. Remember, I do know that my answer will be negative, so keep that in mind, all right? So multiplying this out, this is going to be 1 times 3 is 3, 1 times 2 is 2, 1 times 4 is 4, and the total number of places I have behind the decimal is 1, 2, 3, 4, and 5 places to the right of the decimal there. So I'm going to move the decimal 1, 2, 3, 4, 5 places here in my response and place my decimal. All right, so remember when writing your answer, the answer is negative. So I have my negative showing there, and I have 0.00423 as the decimal, and it's negative, and I'm done. Yeah, and if you look back at your original problem here, if we would have moved our decimal 1, 2, 3 places to the left, we would have ended up with the exact same thing. And I know what you're saying. You're saying, Mr. Witt, where's that red box at? Well, here it is. Okay, there's your red box with a little extra right there. Okay, a little add-on for you. Okay, all right, so that is problem number 8, and now we're looking at problem number 9. In number 9, we have the directions of converting dollars to cents. Converting dollars to cents, ladies and gentlemen. Well, for every dollar, you have how many cents? Exactly. That's exactly right. You have 100 cents, 100 pennies in every dollar. So all you have to do in order to convert dollars to cents is multiply by 100. And if you've been paying attention, multiplying by 100 will move our original decimal 2 places to the right. But I know you want to show your work, so let's do that. We'll have 0 times any number is 0, so I'll just place a 0 there. And then 0, once again for the tens digit, the 0 times anything is 0 once again. And so now I'm multiplying by 1. Okay, so 1 times 6 is 6, and 1 times 0 is 0, and 1 times 7 is 7, and 1 times 5 is 5. And how many places do we have to the right of the decimal? We have 1, 2 places, ladies and gentlemen. So that means I'll be starting my decimal from the right and moving over 2 places to the left to end up with the following. I have an answer that is 5,706 cents. That's it. This is the answer right here. 5,706 cents. That's it. That's the answer to problem number 9. And all we had to do, once again, if you like shortcuts, just move the decimal 2 places to the right, and you'll end up with this response, this answer, this result, this solution right here in the box. That's problem number 9. It's problem number 9. Problem number 10. Problem number 10. We are converting cents to dollars. Converting cents to dollars. Now, when multiplying decimals, all right, and you want to show this as multiplying decimals, you would be multiplying 6,399 times 100ths. Just like that. You'll be multiplying by 100ths, and multiplying by 100ths will be moving our decimal in the original number here, that 6,399. If you were to move that decimal 2 places to the left, you would end up with your result converted. Yeah. It would be the end of the problem. You would have solved it by simply moving the decimal 2 places to the left. But no, not you. You're a hard worker, and you want to show your work. So let's do just that. We have 1 times 9 is 9. We have 1 times 9 is 9. We have 1 times 3 is 3. We have 1 times 6 is 6. Wasn't that fun? Now, how many places do we have to the right? How many digits do we have to the right of the decimal? We have 1, 2 places to the right of the decimal. So you start from the right, always start from the right, always start from the right. And we're going to move our decimal over 1, 2 places to the left, and you're going to end up with the following answer, ladies and gentlemen. That's right. You'll end up with $63.99. Oh, that's an ugly 9. I know. I'm going to fix it. Here we are, fixing that 9. Now, it's better. I don't know what this little hair is. I don't know. It looks like the 9s are furry. If you can zoom in, you're looking at furry 9s. I don't know why they're furry, but that's what they are. They're furry 9s. They're hairy 9s, okay? So that's the answer to problem number 10, $63.99. That's all you have to do. Converting cents to dollars, you move the decimal 2 places to the left. And that's it. All right. Well, that concludes this tutorial on multiplying decimals, ladies and gentlemen. This is Larry Mr. Whittington. Yeah, with Forbidden Tutoring. As always, please rate, comment, and subscribe. If you're able, please donate. Peace.
We certainly hope you enjoyed today's presentation by Forbidden Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? Leave a nice comment. Don't just leave something ignorant on there. If you didn't understand the lesson, ask the professor to explain it for you. Don't just get mad and write something ignorant on there.